Hello, everyone. I just wanted to analyze the airplane force for a moment, and I wanted to share with you some ideas that I'm not sure if it came across in the last section that we covered or not. But when we look at an object that has four forces being applied to it, we can actually break this problem up into two separate problems. We can break it up so that we can analyze the forces along the x-axis, and then we can break it up so we can analyze the forces along the y-axis, creating two separate problems. So the rules that I gave before, where we allowed the summation of the forces along the x-axis and summation of the forces along the y-axis, these rules can be used in order to analyze this problem. Now, the question in the word problem that I gave before was asking you what forces needed to be balanced in order for the airplane to fly. And if we look at the problem and we look at it in two separate axes, we can see that lift and weight have to be equal to each other, and thrust and drag have to be equal to each other. So we can analyze a problem like this by separating them along their axes. So let's take a look for a moment. And here we're going to write what should be equal to each other in this case. So in this case, we know that, excuse me, that lift and drag need to be equal to each other. So we can analyze this. So if we analyze this using the rules, using that summation of forces along the x-axis, where everything to the right, I'm sorry, this is the wrong place to place it, by the way. It should be along the y-axis here because where everything going up is positive here. So we're going to analyze things where up is positive, down is negative. So we get a positive lift, whatever value it has. There's no magnitude in this problem, so therefore we don't have to worry about magnitude. And then we have to add it to the negative weight. Now, because the net force has to equal to zero, we can make this entire equation equal to zero because the net force has to equal to zero. Then we can solve for the problem. And to solve, what we do is we add a positive weight to both sides of the equal sign. And what we get in return is we get that the lift, positive lift, must equal the weight. And in this case, the signs won't matter. So what we're saying here is that in the analysis, we know that to get rid of weight, we always have to add the opposite to it. And then whatever we do to one side of an equation, we do to the other. And we can see that in order for this to be balanced, the lift and the weight must be equal to each other. So if lift and weight are equal to each other, then we have what is called a balanced force equation. We can do the same thing for the x-axis. Now the x-axis, we analyze the forces where everything to the right is positive and everything to the left is negative. So if we look at thrust, for example, if we look at thrust here, thrust is negative because it's going to the left, and drag is positive because it's going to the right. So we analyze the forces here, and we get that plus drag, because it's going to the right, plus a negative thrust is equal to zero. Now, when we say that it's equal to zero, again, net force is equal to zero. We have what is called a balanced force equation. So when we're going to do exactly the same thing we did on the bottom. We're going to add the opposite of a negative thrust to both sides of the equation. of an equal sign. Okay. And then what we get in return is we get that drag is going to equal to the thrust. So this is how we can analyze the forces. And what's really interesting is that when we look at vector quantities can be separated into axes. So we can separate the forces going along the y-axis and separate them from the forces going along the x-axis, and vice versa. So that allows us to analyze it in one direction only at a time. And that's how we use, that's the power of using um, of using forces and vectors.